Hello all, welcome back to my YouTube channel all about VLSI. In this video, we are going to see how to develop our driver and monitor. In our previous videos, we have started our development and completed the development of interface, transaction and your generator. Now in this video, we are going to discuss how to develop our driver file. So let me write down class driver. So this is my driver class. And first of all, let me declare the transaction class handle UART underscore txn h is my transaction class handle, and I'm also going to declare my interface handle as virtual underscore interface UART underscore if is my handle name dot my mod port, that is driver. Okay, and the handle name is VIF. So I've declared my interface handle. Now I'm going to declare three mailbox handles. One mailbox handle for getting the data from my generator. So this is my one mailbox handle, so for getting the data from the generator, and one mailbox handle for sending the data to the scoreboard. From driver to scoreboard we are going to send the data. So why we are going to do so is, without actually getting reading the data from monitor and going to send it to the scoreboard, from the driver itself we are going to send the data which we are getting out of this UART, and that particular data we are going to send it to the scoreboard. Okay, and we are also going to send the data to the reference model. So without actually sending it from monitor, the driver is only going to send it to the reference model. Okay, or else if you want to send the data from monitor also, you can do that. So okay, in my model, what I'm going to do is I'm going to send the data from driver to scoreboard and reference model. So I'm going to first of all declare those mailbox handles, mailbox hash transaction, sorry, UART underscore transaction. One mailbox handle is generated to driver, and another mailbox handle which I'm going to have UART underscore txn is driver to scoreboard, and mailbox hash UART underscore transaction driver to reference model. So I've declared them, and within a new function, mailbox hash UART underscore transaction generated to driver is one argument, and let me copy this too and paste it over here. Yeah, so these are my three arguments which I'm going to have, and let me copy the local handles. So this dot gen2 driver is equal to gen2 driver, and this dot driver to scoreboard is equal to driver to scoreboard, and this dot driver to reference model is equal to driver to reference model. So I've copied it and followed by end function. Now here I'm going to have one task which is known as reset underscore phase. Here what I'm going to do is I'm going to apply my reset signal. So interface handle dot clocking block dot reset is equal to 1, and interface handle clocking block handle dot write enable is equal to 1. Sorry, let me make it as 0, one tick binary 0, and interface driver clocking block dot ready underscore clear is equal to 0. Okay, so I've made it to 0 now. So after 5 clock cycles at passage of VIF dot what are we going to do is we are going to make our reset signal equal to 0. VIF dot drv underscore cb dot reset is equal to 0. Okay, and followed by end task. So this is my reset phase, and now I'm going to write down one more task which is known as run task. So in this task what I'm going to do is I'm going to call this reset phase, and after that within forever begin block I'm going to first of all get the transaction from my generator. How to get it? Mailbox handle gen2 driver dot get of transaction. And after getting that, I'm going to use one more task which is known as send task for sending the transaction. Okay, so let me write down this send task. What is the send task? Let us see. So let me declare the task which is known as send. Now what are we going to do in this send task is we are going to wait for the passage of clock, vif.clock. So vif dot driver underscore cb dot data underscore in. So at the passage of clock we are going to provide the data in that is present in our transaction class txn.data. So from the transaction class, I have told you, right, the driver is basically converting the transaction class objects into pin level objects. Okay, so we are basically collecting the data from the transaction file and we are putting into the interface. And vif.drv underscore cb dot write enable is also equal to 1 tick binary 1. If you want, you can randomize it. I'm basically driving it manually, and at passage of clock I'm making it to 0. vif.drv underscore cb dot write underscore enable is equal to 0. And basically afterwards what I'm going to do is I'm going to wait for my busy signal to be made to 0, not of vif dot drv underscore cb dot busy. So from the interface I'm going to check whether my busy signal is equal to 0 or not. If my busy signal is equal to 0, then I'm going to wait for my ready signal, vif dot driver underscore cb dot ready signal. If this ready signal is equal to 1, sorry, if my busy signal is equal to 0, then I'm waiting for my ready signal to become 1. If my ready signal is equal to 1, then I'm going to display driver data sent. Okay, and I'm going to make my ready underscore clear signal to 1. vif dot drv underscore cb dot ready underscore clear is equal to 1. Okay, and and followed by end task and end class. So this is my driver class. Now let me once again, and in the run task, after using this send task, we are going to put that particular data to our scoreboard and reference model. Driver to scoreboard dot put of transaction and driver to reference model dot put of transaction. So we are putting the data to our scoreboard and reference model and this. So this is how we are going to develop our driver class. Let me recap one more time what are we going to do. So I have declared the driver and also I have declared my transaction class handle and virtual interface handle, and I have declared 3 mailbox handles. One is generator to driver and another is driver to scoreboard and driver to reference model. And with a new function, I'm expecting these arguments to be passed by my environment. So environment is going to pass these arguments whenever it is going to create the instance of my driver, and after that these instances will be created, and I'm going to use a reset phase. So in this reset phase, I'm going to make my reset is equal to 1, write enable is equal to 0, ready underscore clear is equal to 0, and after 5 cycles I'm going to make my reset is equal to 0. Now in the run phase, I'm going to basically call the reset phase, and I'm getting the transaction from the generator class, and after getting this transaction, I'm going to call a task which is known as send. In this send task, at the positive edge of the clock, I'm going to give the data to my design from the transaction class, and also I'm going to provide write enable to 1, and at the next edge of the clock I'm providing write enable to 0. Now since if you are providing the data to your design, the design is going to assert a signal which is known as busy. That means the design is processing your data. Now until and unless your busy is equal to 0, you are going to wait. If your busy is equal to 0, then from the receiver end side we are going to get one more signal which is known as ready. That means the design is ready for another transaction. So if this ready is equal to 1, we are going to use one more signal which is known as ready underscore clear to make this ready signal equal to 0. This is what we are going to do it in the driver. After doing all these particular things, we are going to send that particular transaction class to our scoreboard and reference model. So this is your driver design. So that's all about this particular video. If you like this video, please like, share and subscribe to my YouTube channel all about VLSI. And in our next session, we are going to see the remaining components.